Assalamu alaikum class, hope you're fine. This is your lecture number 15 for grade 8 physics, unit 3 dynamics. So we just review the force and momentum. Just briefly, we already discussed these two quantities in previous lecture. Just recap them. We all know that what force actually is. Force can help us to bring the object in motion when it is in a state of rest. And if it object is moving, you can bring the object in state of rest with the help of a force, right?
Force.
Similarly, you can change the shape and the size of the object with the help of a force. And you also know about momentum. What momentum is? Momentum is basically the product of mass and the velocity, and it's denoted by P, and its formula is is equals to m into v. So I just recap these two quantities because the next topic we will see their relationship in detail, right? Now, force and momentum. This is your main topic. So consider a body of mass m moving with initial velocity v. So see, if there is a body, obviously it has some mass, and if it's in a state of motion, it's mean it is moving with some velocity, and initially it has velocity vi, right? So when force is applied on that body, acceleration is produced, right? How acceleration is produced? If body is moving, when force is applied, its velocity will be changed. When velocity will be changed, then acceleration will be produced in the body, right? So this change in velocity leads to acceleration. The change in velocity, suppose we just stop the object from its initial velocity to the final velocity, and we said that its final velocity as vf, right? So when velocity is producing in an object, it's mean momentum is also there, right? So here we have two velocities, initial velocity and final velocity. It's mean there are two momentums, initial momentum and the final momentum. And mathematically, we can write these momentum as pi is equals to mvi and pf is equals to mvf, right? So these are two momentum. So change in momentum can be written as final momentum minus initial momentum. Change in momentum can be written as pf minus pi. Whenever we are using the word change, we are dealing with the sign of subtraction. Final momentum is vf minus initial momentum, which is mvi. So if the momentum is changing, right, obviously time is also using their because the object is moving, time is also changing with respect to that object. So thus the rate of change in the momentum is given by, whenever the word rate is used, it's mean we are dealing with the time, right? So we just divide t on both sides, pf minus pi by t, which is equal to mvf minus mvf by t, right? And just now consider right hand side. You notice that m is common because mass cannot be changed, right? Velocity is changing, but mass will be remain same throughout the process, right? So we take mass m as common, then we left with vf minus vi by t. And in unit 2 we have learned about that rate of change of velocity is acceleration. So this is basically acceleration, right? So you can instead of vf minus vi by t, you can write a. So just put the value of a over here, write a instead of this value. You can get pf minus pi by t, which is equal to ma. Then you know that according to the Newton's second law of motion, which is F is equals to ma. And your previous equation is also second law of motion is also applying in this equation as well. So instead of ma, you can write directly F over here. So if you just substitute the value of force over here, you get pf minus pi by t is equal to F. So this is the relation between momentum and the force. All right. So this equation defined as force, and now the Newton's second law of motion is defined as when a force acts on a body, it produces acceleration in the body and will be equal to the rate of change of the momentum of the body. All right. So this is the relation between momentum and the force, and it is very important topic. All right, so you have to be go through with this derivation and memorize it by heart. And you all know that the units of momentum are kg meter per second. But see here, you see here, F is equals to pf minus pi by t. So if you find out the unit of momentum, you just take t over here, and you know that the unit of force is Newton and the unit for time is second. So in this case, the units are Newton second. So the unit of momentum are Newton second, but in previous lecture you learned that the unit are kg meter per second, and both unit are equal, right? So if you take as a left hand side, which is Newton second, and you put the value of Newton, which is kg meter per second square, multiply by this s, you get kg meter per second. These two s are the bases are same, so you will add the power. So minus 2 plus 1 give you minus 1. So these are equal, which is equals to kg meter per second, and which is equals to right hand side. So both units are fine, but the SI units are Newton seconds, and you can use both units. Both units are correct. All right. Now, useful information. This information is also related, the topic, the relation between momentum and the force. Fragile objects such as glasswares, etc. are packed with suitable materials such as styrofoam rings, balls, polythene sheets with air sacs, etc. So fragile objects are those objects which are easily broken. Means these objects are very sensitive, and we are taking the example of fragile objects such as glasswares. Glasswares are those objects which are made up from glass. In laboratory you see beakers, thermometers, funnel. These are all are made up of glass. They are generally we call them glasswares, and they are basically come under the category of fragile objects. So these objects are very sensitive, and we know that they can easily be break. So what we do pack in such a material to keep them safe from damage, right? So styrofoam rings, you already know that you have seen disposable white boxes in your house, disposable cups, and sometimes you pack things in it or use. So these are basically styrofoam rings which are used to pack them, right? Then polythene sheets, they are basically a plastic films. You all are aware of plastic bags which you are generally use in your home. So sometimes you when you take these objects, you just wrap them in the plastic bag. So here we use polythene sheet with air sacs. Most of you are aware from bubble wrapping. So what you do when you take these objects, you do a proper packing, like in plastic bags with bubble wrap, and these styrofoam rings to avoid the damage. So suppose air enclosed in the cavity of these material make them flexible and soft. During any mishap, they increase the impact time on fragile object. An increase in impact time lower the rate of change of momentum, and hence lessen the impact of force. This lower the possible damage to an accident. So what happened might be some mishap happens to you, and might be they fall. So because of wrapping in these kind of sheets, they increase the they increase the they increase the impact they increase the impact time, and they lower the rate of change of momentum, and hence the force will be less. So in this case the damage will be occur less, right? So this application of momentum and force they are using in our daily life as well to save the different objects. All right. Second useful information, in an accident at high speed, the impact force is very large due to extremely short stopping time. Sometimes when the car is coming with overspeed, so accident mostly occur because of overspeed, right? So sometimes what happened, the driver just apply the brake, but time is too short to apply the brake, that he gets some he have to move in the forward direction, or might be some accident occur, right? So for these safety purpose, vehicles have rigid cages for passengers with crumple zones at their front and and rear ends. Front and rear ends mean at the front side of the car and the back side of the car, there are some crumple zones, right? Crumple zones are basically the safety features that is used in the vehicle to increase the time over which the rate of change of velocity and the momentum impact will be less, and the object and the force the force that is applied is also less, means the change in size and the shape of the object can be controlled. It can be less because of these crumple zone. So during an accident, crumple zones collapse. This increase the impact time by providing extra time for crumpling. The impact of force is highly reduced and save the passenger from severe injuries. So in cars, we are using crumple zones, which are working on the relation between momentum and force, which save the passenger if accident occur. The passenger will be saved because of these crumple zone, because there is the rate of momentum is very less, the force is very less, because the time will be increased because of these crumple zone, and they can save the lives of people, and there is a less chance of injuries if these crumple zones they are used in the vehicles, right? So this is also the relation we are seeing over here, that the relation of momentum and the force is also applying over here in our daily life. Now, example 3.6. A body of mass 5 kg is moving with a velocity of 10 meter per second. Find the force required to stop in 2 seconds. So mass is given over here, which is 5 kg, and velocity is 10 meter per second. And now you have to find the force required to stop it. Stop mean you have the final velocity which is equals to 0 meter per second. Whenever the word stop is used, it's mean you are dealing with the final velocity which is equals to 0 meter per second and 2 seconds, and the time is 2 seconds, right? So you know the relation, this is our relation basically, and you have to put the value in this relation, right? So first of all, you have to find the value of pi, then pf, and then you substitute the value in this formula and you get the value of force, right? So pi will you get pi the value, multiply m with vi, you get 15 newton second, and pf is when you multiply m with vf is 0, so here the momentum is 0. So just substitute the value, which is 15 newton minus second minus 0 newton second divided by 2 second, which give you 25 newton. This is the required force to stop the body. Now, law of conservation of momentum. Before going to this main topic, I just want to clear you these terms which are very important. Momentum. You all know about momentum. Momentum is the product of mass and velocity. System. System is new things to you, right? System is basically made up of two or more than two bodies. When when there are two or more than two bodies are involved, it makes a system. It means it makes a group. A system is a group of bodies within certain boundaries. So system is basically a group which has two or more than two bodies, and they are existing in a certain boundaries. All right. Then an isolated system. Isolated system is that system in which no external force is acting on it. Means if there is a group, there is a force within the group. The force they are interacting, bodies are interacting within the group, but no external force is applied in the system, right? So that system is known as isolated system. Means a system in which no external force is applying on the group. All right. So an isolated system is a group of interacting bodies on which no external force is acting. If no unbalanced or net force acting on a system, then according to the equation 3.14, its momentum remain constant. Equation 3.14 is that equation which we just did, pf minus pi by t, which is equals to f. All right. So these three are very important definition while studying law of conservation of momentum. Now, the law of conservation of momentum. Conservation mean remain same, unchanged, remain constant. When thing is not changed, we say that they are conserved, right? So the law of conservation of momentum is stated as the momentum of an isolated system of two or more than two interacting bodies remain same. Means their momentum is not going to be changed. All right. So this definition will be clearer with this example. Uh, let's say an example. Consider the example of an air-filled balloon as described under the third law of motion. Also keep in mind when you are dealing with law of conservation of momentum, keep in mind there is always a third law of motion. All right. So we already discussed this example in our third law of motion, right? So consider the example of air-filled balloon. So there is an air-filled balloon, and initially you know that balloon is air-filled and it is in the state of rest because there is no motion, right? When there is no motion, it means it velocity is zero, and it obviously it has some mass, right? So what happened when we release the balloon? The balloon is start moving. It will just moving in the forward direction, and the air is blowing out from the balloon in the opposite direction, which is basically the third law of motion. When we set the balloon free, balloon is moving. When balloon is moving, it's mean it has some velocity, it gains some velocity. When it gains some velocity, it means there is a momentum, right? So it produces a momentum. Initially, when balloon is filled with air, it is at rest. The momentum is zero because velocity is zero. But when we set free the balloon, what happened? It start moving and it gains some velocity. Means now it has some momentum. It is moving with some momentum. To conserve the momentum, the balloon move in direction opposite to that of the air rushing out. So and our main aim is to keep the momentum unchanged. So how we can keep the unchanged momentum? See, if balloon is moving in the forward direction, in the opposite direction the air is coming out, and at some point balloon will again in the state of rest, means again the velocity will be zero. So the momentum of an isolated system of the object is remain conserved. Means force is means there is a velocity, but this interaction is within the group. No external forces applying. It is in the force. The air is filled within the balloon, so that's why balloon we set free that it's moving. The force initially it has inside it has, right? So there is no external forces applying on the balloon. Balloon is just moving within the certain boundaries, and it is an isolated system. So this is an example of law of conservation of momentum, and your concept will be more clear with this example. We take another example. Consider an isolated system. Again, you know that what is isolated system, right? There are two sphere of masses m1 and m2 shown in figure 3.14c. This is mass m1 and this is mass m2. Both are sphere, and you by figure you can see that mass m1 is small as compared to the mass m2. They are moving in straight line with initial velocity u1 and u2. These arrow, they are showing that they are moving in a straight line, and their initial velocities are u1 velocity for mass m1 and u2 velocity for mass m2, right? And the condition is given over here that u1 is greater than u2. All right, the velocity for mass m1 is greater than for velocity of mass m2, right? Because if this object is because this object has small mass, obviously it has more velocity, right? This is also a general. But now just look at this picture, and we will write the momentum from this diagram, right? So the initial momentum of mass mi is m1 u1, right? And for the mass M2 is M2U2. These are two initial momentum for sphere M2, M1 and M2. And as we have only two bodies over here, so we add them to get the total initial momentum. So the total initial momentum of the system before collision is M1U1 plus M2U2. This is basically the initial momentum of the system when there is no collision. They are just moving in a straight line with their respective velocities that are assigned to them, right? But there is no collision occurring. But what happened after some time? What happens over there? See, the mass M1 hit to the mass M2 because M1 has the more velocity, so it's come near to the M2, and collision is applying over here and just hit the mass M2. So when it hit the mass M2, Newton's third law of motion is applied over here. M2 exert an equal and opposite reaction force on M1. When it exert equal and opposite force, they again become like this, right? So after this, their velocity will be changed. The velocity of for M1 will be now V1, and the velocity for M2 will be now V2, right? So we can write their final momentum. Final momentum of mass M1 is M1V1, and final momentum for mass M2 will be M2V2. All right. Now, if we want to write the total final momentum of the system after collision, it will be M1V1 plus M2V2. We just add the final momentum of the system. Means there are two spheres, they are making the system. We can just add them, right? So according to the law of conservation of momentum, total initial momentum of the system before collision is equal to the final momentum of the system after collision. So what we do, we just write the initial momentum over here and a final momentum over here, and they both are same, they are unchanged, they are again moving in the same direction after the collision. So this equation clear that the momentum of an isolated system before and after collision remain the same, which is the law of conservation of momentum. There is also another example of momentum, and this example is also very important, right? So this will also clear your concept regarding conservation of momentum. Consider a system of a gun and a bullet. See, these are two bodies, they are making a system. I mentioned you that two or more than two bodies, they are making a system. So there are two bodies, gun and bullet, they are making a system. Before firing the gun, you have noticed that gun and bullet, they before firing, they are at the rest. When they are at the rest, it's mean they have mass. Gun has different mass, bullet has different mass, but their velocity is zero because they are at rest. So their total momentum of the system is zero in this case, means their initial momentum is zero because they are not in state of motion, they are at rest. All right. So as the gun is fired, bullet shoot out of the gun and acquires momentum. Obviously, when gun is fired, bullets shoot out from the gun, it will move with some velocity, and when it has mass and it is moving with velocity, it will gain the momentum. To conserve the momentum of the system, what happened when we fired the gun will recoil. Recoil mean the backward force is sudden backward force is applied to the gun. You have noticed whenever you just fire the gun, the gun is also recoil, means it just moved backward with some sudden force, right? This is basically a recoil. So this is basically a conserved momentum, right? Bullet is moving in the forward direction, bullet is moving with some velocity and gaining some momentum. On the same hand, gun is recoil, mean gun already has mass. When it's recoil, it a sudden backward force is applied to it, it's mean velocity is also over here, so it also gain the momentum, and the momentum remain conserved because bullet is moving in the forward direction and the gun recoils. So according to the law of conservation of momentum, the total momentum of the gun and the bullet will be zero after the gun fired, right? It's again when the gun is fired, it again will be at the state of rest. after finding the right. So as bullet is small, so we take its mass with small m, and it velocity with small v, right? And as gun is in large size, so we keep it mass with capital M, and its velocity with capital V. So we can initially the momentum of the gun and bullet is zero, but after firing it gains some momentum. So the total momentum of the gun and the bullet after the gun is fired is mv plus small mv, right? So according to the law of conservation of momentum, total momentum of the gun and the bullet after the gun is fired is equal to the total momentum of the gun and the bullet before the gun is fired. All right. So this is our final momentum. This is our initial momentum is zero. We write this equation. We keep mv on the left hand side, move small mv on the other side, it will gain negative sign. Then if we find out the velocity of the gun, we can write the formula as v is equals to minus m by m v. So equation 3.19 gives the velocity v of the gun, and negative sign indicate that the gun is opposite to the velocity of the bullet, means gun recoils. Because of the gun recoil, we have the negative sign over here. Since the mass of the gun is much larger than the bullet, therefore the recoil is much smaller than the velocity of the bullet. So in all cases, we are seeing that law of conservation of momentum is applying over here. And very useful information, it is also related to the momentum. In case of an accident, a person is not wearing seat belt will continue moving until stopped suddenly by something before him. Uh, This something may be a windscreen, another passenger, and or back of the seat in the front of him or her. Seat belts are useful in two ways. You know that when driver is not wearing the seat belt, obviously he is moving forward, and he will stop with the help of a steering or windscreen or some person, right? So there are benefits when we're driving a car, and these benefits, they are basically the application of a momentum and a force. We can read over here. They provide an external force to a person wearing seat belt. So force is applying with the help of a seat belt. The additional time is required for scratching the seat belt. This prolongs the stopping time for momentum to change and reduce the effect of collision. So because of this, what happens, seat belt, it will increase the time, and the effect of momentum will be lower, and there will be a less chances that a person will be collide, and he will be get in danger, right? There will be less chances because of seat belt. So it is also an application of momentum and force over here. So again, example 3.7, a bullet of mass 20 gram is fired from a gun. So mass is 20 gram, your SI units is kg, so you have to divide this 20 gram with 1000, and you get the proper unit like 0.02 kg, right? And whenever you keep in mind, whenever there is a mass of bullet, you will write with small m, and the velocity, and with a muzzle velocity is always a velocity of bullet, so you also write with small v, which is 100 meter per second. Then find the recoil of the gun. Recoil mean you have to find the velocity of the gun if its mass is 5 kg, so capital M for gun. So you know this formula, and you already know the we have done the formula, v is equals to minus mv by capital M. Just substitute the value and you get the value minus 0.4 meter per second, and you note that this minus sign is basically the because of the recoil of the gun, right? So this is your homework. How can you relate a force with a change in momentum of a body? So you have to just do the derivation of force and momentum, which we discussed in the start of lecture. Then state question number 2, state and explain the law of conservation of momentum. You have write the law of conservation of momentum and explain with the help of different examples. There are 3 examples: a balloon, and a second one is 2 spheres, and third one is bullet and gun. So you can mention these examples to explain the law of conservation of momentum. So this is your homework. If you have any question, you can ask me, right?